Hey everyone, and welcome to today's discussion. We're diving headfirst into the amazing history of computers, from clunky mechanical contraptions to the sleek smartphones in our pockets. It's a wild ride, and I'm super excited to explore it with you. So what's the very first thing that pops into your mind when you think about the history of computers? Like, what's the earliest thing you can imagine that might be considered a computer?
Well, for a beginner, the most intuitive starting point is probably something really simple, like the abacus. It's ancient, super basic, but it totally fits the bill as a calculating device. Imagine trying to do your taxes without one. It would be a nightmare.
An abacus, that's a great place to start. It's so simple, yet it represents a fundamental human need to count and calculate. But let's jump ahead a bit. What about something a little more sophisticated? What's the next big leap in this history?
After the abacus, we see a huge gap. Then the Antikythera mechanism pops up. This thing is mind-blowing. It's an ancient Greek device, basically an analog computer that predicted astronomical events. It's like seriously impressive engineering for its time. It shows that the desire to automate calculations is ancient.
Wow, an analog computer from ancient Greece? That's incredible. It really shows that the idea of a computer has been around for a long, long time. So what happens next? How do we get from these ancient devices to the computers we know today?
The next big step is the 19th century, with Charles Babbage and his amazing, albeit mostly theoretical, machines. He's often called the father of the computer, and for good reason. He designed the difference engine and the analytical engine.
Charles Babbage, the father of the computer. That's a name I've heard before. Can you tell us a bit more about his inventions, what made them so revolutionary?
The difference engine was designed to calculate polynomial functions, creating mathematical tables automatically. But the analytical engine was even more revolutionary. It was designed to be programmable using punched cards, just like the Jacquard loom used for weaving. It had all the basic components of a modern computer: input, processing, memory, and output.
Punch cards. That's fascinating. So it was basically a mechanical computer that could be programmed? That's a huge leap forward, but it sounds like it wasn't actually built, right?
Exactly. Sadly, due to the technology limitations of the time, Babbage never fully built a working analytical engine. But his ideas were incredibly influential. And we can't forget Ada Lovelace, his collaborator, who's considered the first computer programmer.
Ada Lovelace, the first programmer. Amazing. So we have these incredible theoretical machines, but it takes a while before they become a reality. What's the next big breakthrough?
The next big jump is the integration of electricity. We start seeing electromechanical computers using relays and punched cards. Herman Hollerith's tabulating machine used for the 1890 U.S. Census is a great example. His company eventually became IBM.
IBM, so the company we know today started with a machine designed for the census? That's wild. What comes after electromechanical computers?
Then comes the electronic revolution. Vacuum tubes replace relays, making computers much faster and more reliable. The ENIAC, built in 1946, is a prime example, a huge, room-sized computer that used over 17,000 vacuum tubes.
17,000 vacuum tubes? That's insane. It must have generated a ton of heat. What was the next big improvement?
The invention of the transistor in 1947 was a game changer. It was smaller, faster, more reliable, and used less power than vacuum tubes. This ushered in the second generation of computers.
Transistors, a tiny component that revolutionized the entire field. What came after transistors?
Then came integrated circuits, or microchips, which packed tons of transistors onto a single chip. This led to the third generation of computers, which were even smaller, faster, and cheaper.
Microchips, putting so much power into such a small space, that's incredible miniaturization. What's the next big thing?
The microprocessor. Putting the entire CPU onto a single chip. This led to the fourth generation of computers and the personal computer revolution. Think Apple II, IBM PC. Computers became accessible to everyone.
Personal computers, that's when computers really became part of everyday life. What's the next chapter in this story?
The networked age. The internet connected computers globally, leading to the World Wide Web, email, and everything we use online today.
The internet connecting the world through computers. It's hard to imagine life without it now. What's the latest development in this ongoing story?
We're now in the age of mobile computing, cloud computing, and artificial intelligence. Smartphones, cloud services, and AI are shaping our world in incredible ways.
AI, cloud computing, smartphones, the evolution continues at an incredible pace. It's amazing to see how far we've come from the abacus. This has been a fantastic discussion on the history of computers. Thank you.